Hi, welcome everyone. Welcome to the third talk of ZuriHac. I hope you all had fun so far with the project and the tracks this afternoon or evening or morning, depending on where you are, of course, in the world. So for the next talk, we're delighted to have Gabriel Gonzalez. You may know him from DAL, the configuration language, or Pipes, the streaming library, and of course, there's his blog, haskellforall.com. If you have any sort of questions during this talk, you can post them in the talk discussion channel on our Discord instance, and we'll try to answer them for you. And okay, take it away, Gabriel.
All right, give me a chance to share my screen. Okay, first, before I begin, I wanted to thank all the organizers for making this possible. This is also my first time giving a talk remotely, so this will be a lot of fun for me too. And I look forward to interacting with all of you at ZuriHac. I will have explicit points in this talk where I will pause and take questions. Because there is a delay of maybe 10 to 20 seconds, queue up your questions early so that there's enough time for me to get to them during those pause points. Okay, so my name is Gabriel. I'm a software engineer at Awake Security, and today I'm going to be talking about building a bare bones Twitter clone implemented using Haskell and Nix. And so I imagine most people watching this are probably already familiar with Twitter, but for people who are not, Twitter is a social media website where you can author tweets, which are up to 280 characters long, and you can follow people. And when you follow people, you subscribe to a feed of their tweets. And that feed of all the people that you subscribe to is called your timeline. And Twitter actually offers several other features, but that core functionality of following people and authoring tweets and viewing timelines is what we're going to be implementing in our simple Twitter-like prototype. So let me show you what the final product is going to look like, and then we'll get into how we're actually going to build that final product. So I'm going to switch this tab right here. So it's not anywhere nearly as visually appealing as Twitter. It's very simplistic, but this is actually live and working right now. So if you would like to participate and use this simple Twitter website, I'm actually going to post the link to the website in the talk discussion channel. And my only request is don't delete other users or comments that you see, mainly so that I can just use this to demo the talk. My second request is keep it family friendly. So I'm going to be looping back to browse what's happened so far at the end of the talk. So let's go through what are the core functionalities that we're going to implement. So the first button here in the default when you get to the landing page for this site is called the global timeline. So this global timeline is a throwback to the very early days of Twitter. Back when Twitter was a much smaller site, you could actually view a feed containing all tweets from all users. Now that's not realistic anymore, but for this simple Twitter, since we don't have a lot of users, we can still do that. And so if you click the global timeline button, yeah, see, we can already start seeing some tweets from people who have begun participating. You can create a user. So for example, I'm going to create a user called delete me. All right, and this gives us, and whenever you create a user, it'll give you a list of all users that have been created so far, one of which will be the delete me user here at the bottom. And you can author a tweet by saying, delete me, and then this is don't delete me. That'll create a tweet. When you do so, it'll take you to that user's profile page and show you the timeline of tweets that they've authored. A user can follow another user. So you can say delete me is going to follow, in this case, my account, Gabriel. And now it'll show that the delete me user follows Gabriel. And now this is the timeline for this user, which includes my tweets. And then we can get a specific user's profile, such as my own profile. And so that shows my history, my timeline, and the people that I follow. And then finally, we can delete the user, and it's as if they were never there in the first place. So this is what we're going to be building in Haskell and Nix. And so this Twitter clone is going to be implemented as a multi-page web application. And in upcoming slides, I'm going to talk about what that means if you're not familiar with web application development. And we're going to be doing so using a combination of Haskell and Nix. And there actually are a lot of simple Twitter prototypes out there on GitHub. And the thing that makes this particular prototype novel is that the entire implementation fits within a single file, including the logic for how to deploy the website. And it's less than 500 lines of code. Most of the code is going to be Haskell, And the majority of the talk is going to be about Haskell, but we're also going to introduce some Nix along the way, and also some database and database logic and SQL along the way too. And if you'd like to, most of the code excerpts from this talks are going to be incremental additions to a starting example. So we're very rarely going to see the full code example on any one given slide. But if you would like to see the full example while following along with this talk, you can visit this link to view the slides. So actually, I'll share that in the talk discussion channel too. And that repository contains the complete implementation, and it also contains a link to these slides if you also would like to follow along the slides on your own screen for whatever reason. So the way I'm going to organize this talk is, first I'll talk about how web servers work, just to give an introduction for people who are not familiar with web application development. Then I'll talk about how to deploy a blank server using Nix, specifically using Nix Ops. And then we're going to add a database to the mix so that we can begin building our domain model for our simple Twitter website. And then in front of that database, we're going to create a Haskell HTTP service so that we can begin serving HTTP requests that interact with the database. And then the final section of the talk, we're going to take the results received from the database and render them in a pretty way using HTML or CSS. Are there any questions before I move on really quickly? Okay, looks like no. If you do have questions, again, just queue them up asynchronously in the background, and the next time I will pause to get questions, I'll read them out. Okay, so if in web application development, you can think of there being two extremes. One extreme is multi-page web applications, and the other extreme would be single-page web applications. You can think of multi-page web applications as ones that are more devoid of JavaScript, meaning they rely more on simple features like links or forms to navigate between pages. Whereas single-page applications tend to be very JavaScript rich. They tend to use one page, and they use JavaScript calls to make requests to the backend server, and then they mutate the page that you're looking at in place. So multi-page applications, the primary mode of navigation is you click a link, which creates a GET request to some backend server, or you submit a form, which creates a POST request to some backend server. And then typically the HTML is rendered server-side, and then that will just load a new page. That's why it's called a multi-page web application. In a single-page web application, every time you perform some action, the JavaScript will make what's called an AJAX call to a backend server. And that can use basically any HTTP method, whatever you want. And the result will typically come back as a JSON payload, which the JavaScript code will then interpret to modify the current web page that you're looking at, so it doesn't trigger a new page load. Now, you can think of these as being two extremes of a spectrum, and many web pages lie somewhere along the middle of that spectrum. For example, if you were to go to github.com, whenever you click on, say, an issue or the Issues tab or the Pull Request tab, that will navigate to a new web page. But say that you visit a particular issue and you create a comment. So in the act of creating a comment will actually modify the page that you're looking at in place. So GitHub is kind of a mix between the two styles of designing a web application. In fact, most pages are somewhere in between and aren't really at the extremes. There are two Haskell web frameworks that I think of as being emblematic of the two web application development styles. So one is Yesod, which is primarily designed to support multi-page web applications. And then there's Servant, which is primarily designed to support single-page web applications. But they can both be used for the other use cases as well. So you can create a single-page web application using Yesod, I think. I've never tried it, but I assume you can. And I know for sure that you can create a multi-page web application using Servant, because that's actually what this talk does. We're going to be using Servant in a slightly non-idiomatic way, where Servant, instead of serving something like JSON, is going to be serving a server-side rendered HTML. And the reason I went this route is because it's the simplest to demo and leads to the most concise code, but it's not necessarily the approach that I would use for real production code. So the way information is going to flow in this web application is that we're going to have the user's browser, which is going to make an HTTP request to some machine that resides in EC2. And so this machine will have two main services residing on that machine. One will be a Haskell HTTP service, and the other will be a Postgres database service. So both of these services will be residing on the same machine. And so an incoming browser HTTP request, such as a GET request, will be translated by the Haskell service into a database request, either a query like a select statement, or a command like an insert statement. And if it's a query, the database will return some results back. If it's a command, it won't. But either way, the Haskell will then interpret that to serve back HTML to the browser, which the browser will then render as a web page. Are there any questions about any of that before I move on? All right, it looks like no questions so far. Feel free to queue up more if you have any. So now we're going to talk about how to deploy a blank server using Nix, and specifically Nix Ops. I don't expect you to memorize this code that I'm showing in front of you. The way I found this code is I just searched for the Nix Ops manual, which has a section dedicated to how to deploy an EC2 server, and I cribbed a lot of this code from that section. The key parts that I want to highlight here are that when deploying to EC2 using Nix Ops, you can specify the region, and you can specify what platform you're deploying to. So Nix Ops actually supports multiple platforms, multiple cloud providers, like Google Cloud and probably Azure. I haven't really checked. You also don't need to use Nix Ops to provision the server. For example, let's say that your company prefers to use Terraform to provision servers out of band. You can do that, and Nix Ops can deploy to servers that have already been provisioned by some other tool, as long as you give it the address of that server and a way to log into that server using SSH. But here we're going to use Nix Ops to do everything. You can also specify what server size you want. So here we want the smallest server size, which is a T2.nano server. We don't need a large server because we don't need to build the Haskell code on the destination server. Instead, Nix Ops actually provides a lot of flexibility about where the code can be built. You can build it locally on your own machine, or if your own machine is not the right operating system type, for example, let's say your machine is a MacBook, you can delegate the build to a larger Linux machine, perhaps one in your company's data center, or maybe a Linux desktop you have sitting around your house. And then that way, all you have to do is you build out of band, and then Nix Ops can then transparently copy that to the destination machine rather than having to build on the destination machine. All right. So if you take that previous Nix file and you save it to simpletwitter.nix, then there's a one-time setup command that you run called Nix Ops create. You give it a name of the deployment, and then it associates that name with the deployment file. So then all subsequent commands can just use the deployment name. This comes in handy if your deployment logic is split over more than one file, which Nix Ops permits. And then from that point forward, anytime you want to apply the changes that you've specified in your deployment file, you just need to run Nix Ops deploy and then the deployment name, which in this case will be simpletwitter. And Nix Ops will download or build everything that the deployment needs, copy to the destination machine, and activate or start up any services that the deployment depends on. One of the things that I like about Nix Ops is that in the process of applying a deployment, it will only copy over the diff, meaning that only the things that have changed since the last deployment. It will also only activate the diff, meaning that we'll only restart services that have changed since the last deployment. And it can use Nix's intelligent dependency management to automatically detect which services need to be changed. In this case, though, our service is just a blank service. So the only interesting thing on it at the moment is the SSH daemon. So I'm just going to log into that machine using Nix Ops SSH and verify that SSH daemon is working, which obviously it is, since I was able to log into the machine. And one of the things I really like about Nix Ops is really the fact that it uses Nix OS. And Nix OS is short for the Nix operating system. And the Nix operating system has a really nice feature, which is that every interesting thing that you want to do with the operating system can be configured using a uniform option syntax called the Nix OS options system. So for example, if I want to open up port 80 in my machine's firewall so that I can serve an HTTP server, I just say networking.firewall.allow TCP ports equals 80. And then I can apply that change by running Nix Ops deploy simpletwitter. And then it will copy over some configuration files related to the firewall. It will only activate the firewall service because it detects that that's the only thing that changed since the last deploy. And this is just a simple systemd service, which is responsible for applying firewall changes. It's specific to Nix OS. And then I can verify on the machine that the firewall is indeed open for port 80. And you might wonder, how do you even know what options are available for you to set? And there's a really awesome site called that you can use for browsing the available Nix OS options. So I'm actually going to visit this site right now. So here, for example, if I search for firewall, it gives me a whole bunch of firewall-related options that I might be interested in. If I click on Allow TCP ports, it'll tell me first off, it'll give a description of what this option does. It'll tell you what's the default value. It'll tell you what's the type that the option expects, and that type is checked. And then also it'll give you an example value. And here's a really cool feature. It will also contain a link to the code that declares and implements that option if you want to better understand the nitty-gritty details of how that option works. And then you can really configure anything about your system in this way. So for example, I can configure kernel parameters using this option. Or if I want to use an encrypted disk, I can configure that using the same uniform option syntax. Any questions about that before I move on to the next section? Okay, hold on. Let me read through these. Is authentication an issue with Servant? For example, for a Twitter clone. I would say it's not an issue, meaning you can implement authentication with Servant. So for example, we do this at work. We use Servant, and we implement our own authentication mechanism on top of Servant. Recently, I believe Servant has started to implement sort of a standard framework for authentication, but it's not going to be necessarily as out of the box as you might have with, say, a web framework in another language, like, I don't know, Ruby on Rails. I've never used Ruby on Rails, but I assume it's much more complete than what Servant would provide, for example. So you can totally do it, but you may need to still do a lot of the wiring up of things yourself. So the next question is simpletwitter.nix a generated file? It looks like it has, in the repository that I linked to, it looks like there's a main.hs and a split.nix in that repository. Actually, so in the repository that I mentioned earlier on the talk, it includes both the complete all-in-one file, and it includes also each language split out into a separate file. And that's mainly, and the latter set of 3 files is more for the convenience of reading them if you prefer to have them split up. But none of those files were generated. So the complete all-in-one file was actually just authored by hand, and then I just manually split into 3 files for convenience, mainly so you can just browse them with syntax highlighting. The next question is, where is the list of Nix Ops deployment that you've added stored? So there is a local SQLite database underneath your home/.nixops directory where it maintains this state. This is actually one of the biggest deficiencies with using Nix Ops, which is that it doesn't have, well, at least, I don't know if this has changed recently, but last time I checked, it does not have a good story for sharing this deployment state between multiple users, let's say within organizations. For example, if you compare to, say, Terraform, right? In Terraform, you can keep your deployment state in S3 with appropriate encryption and authorization mechanism, so that you can so that several developers can contribute and modify the deployment in a sane way. So Nix Ops doesn't have a really good story for that, and I think that's one of the biggest deficiencies in using Nix Ops. And so another question is, how does config kernel parameters work in AWS? The answer is I don't know if that particular Nix OS option works for AWS or not. I've never tried it. This is one of those things where, like, I think the easiest way would be just try it and see what happens. All right, I think that's it for these questions. So I will move on to the next section of the talk about how to add a database, a Postgres database specifically. So the first thing we need to do is we need to decide on what is the actual database schema. So this is the part where we start thinking about our domain model for our simple Twitter website. And for people who are not really familiar with authoring databases, so personally, I'm not even an expert on authoring databases. I know enough to be dangerous. So one thing I do know about authoring databases is that you want to try and make it so your schema is in what are called normal forms. So they have like first normal form, second normal form, third normal form. And you can think of normal forms as sort of like the database version of making invalid states unrepresentable. So database people have the same needs as Haskell programmers who also like to make invalid states unrepresentable. And so I have a simple rule of thumb I like to apply, which helps me create database schemas, which tend to be in third normal form, which removes a lot of potential for data inconsistencies. And the rule of thumb I like to use is, first, think about what are the nouns in your web application. So this is a Twitter-like site. So the 2 main nouns are users and tweets. And so for each type of noun, we're going to create a table. So there's a users table and there's a tweets table. And then after that, you think, what are the edges between those nouns? So for example, when a user authors a tweet, you create an edge between that user and that tweet. Similarly, when a user follows another user, you're going to create an edge between those two users to represent the follow relationship. So you create one table for each set of edges. So this is the table for edges between users and tweets. And this is the table for edges between users in the form of follow relationships. And that's it. That's going to be the only schema we need for this simple Twitter-like website. I won't go into too much other details about the schema. If you would like to learn more, feel free to ask me after the talk. And so to create the database, we do that using Nix OS options. So provisioning a Postgres database uses the same uniform Nix OS option syntax. So we say services.postgresql, and then we can set a family of Postgres-related options. Enable equals true will just make sure the database is there, and we'll do everything. It doesn't just install the Postgres executable. It creates the systemd service. It creates the relevant users, and so forth. These options right here are related to authentication. I'm not going to go into detail about why we need them, but we do. And this one's interesting. So you can also tell Nix OS what version of Postgres should I be using. For example, at the time I authored this, the default Postgres version that Nix OS selected was Postgres 9, but that didn't support some of the features I needed for my database schema, like this current timestamp utility. So I just say, okay, I want Postgres 11, and it's as simple as that. And then Nix will make sure to download and include that in the installation. And then there's a useful option for demo purposes called initial script, which you can give it an SQL file, and then it will run that file only once, and then you'll make sure never to run it again. I wouldn't really recommend this for provisioning a schema in production. So usually in production, what you will tend to use is some sort of schema evolution tool to migrate the schema as your product evolves. For example, at work, we use Liquibase for that purpose. But this option is just fine for demo purposes, so I use it here. And then we apply the deployment the same way as before. So we run Nix ops deploy, and then it will download the right version of Postgres, copy that to the machine, wrap it in the right systemd service, and then start it up, and then provision the right database users, run the schema setup script, and then we can log into the server and verify that all the tables that I need are there, and we're ready to build out our Twitter web app. So any questions before I go on to the Haskell section of the talk? And the one user notes, the schema seems a bit too normalized. Tweet could have an author field. Yeah, you could make the schema a little bit smaller by not factoring things out so aggressively. I tend to do it just because I like to have a very opinionated way of doing things, so that it just requires less thinking on my part to figure out how to do it. I don't like to have lots of room for taste in the way things are done. And the next question is, could you use Nix to provision an RDS instance? I don't know off the top of my head. The way you would know for sure is go to the Nix Ops. So search for Nix Ops manual on Google, and then the Nix Ops manual will have one section of the manual for each supported deployment type. I believe also newer versions of Nix Ops support a plugin system, so that if you want to add Nix Ops support for a new type of backend format, you can do so. So yeah, I think in general, it's customizable to a fault, as many Nix things are. So it should be possible in principle, although I don't know the details of how to do it. So the next question is, how is Nix Ops running on a non-Nix OS system? So Nix Ops can actually be run on any platform, right? Nix Ops is just a Python program that's built using Nix. And that Python program then provisions some machine, and the machine that you provision is a Nix OS system. So if Nix Ops provisions that machine, it will definitely be Nix OS. Even if you use an already provisioned machine, that machine that you provision will also need to already be a Nix OS system. So it's not like it can take over an Ubuntu system and make it work. That won't work. So the next question is, does Nix Ops provide any support for doing maintenance things like complex upgrades on stateful machines like Postgres? I think you can always just log in to the machine. So you can use Nix Ops SSH. And so if you want to do your own stateful automation on that piggybacks on top of Nix Ops SSH, you can do it that way. I don't really have more detail to add beyond that. So the follow-up question, are provisioned resources such as RDS instance via Nix declarative, meaning it's a no-op if the resource already exists? It depends. So there's two aspects of that. So there's so let's distinguish between what Mixups provisions and what Nix OS manages, right? So Mixups will manage several EC2 related things. So things like, instances or security groups or S3 buckets, things like that, or keys and credentials or keys, right? And so for those things, yes, Mixups will in fact do it declaratively, meaning that it will only deploy the diff. So like if it detects that S3 bucket, for example, is already there, then there's nothing to change, and then it just deploys that, and then it does nothing. The same is true for the things that Nix OS manages. So like a database, if there's it detects there's already a Postgres instance running on the particular machine, it's not going to deploy a new one. So right, so it's they're both idempotent for the things that they respectively manage. And the next question is, does each deployment via Mixups generate a new generation in Nix on the server side? Yes, it does. You can buy I don't know if it does it by default, but there definitely is an option that controls whether or not Mixups stores generations for each new deployed version. I think when I first tried Mixups, this was not the default, but I know there is such an option, and you can set it to be true. So the one person asked to clarify, so is the target of Mixups need to be a Nix OS system? And the answer is yes. Mixups can only manage Nix OS systems as far as I know. All right, so I think that's the end of this batch of questions. So I'll go back to the talk. So now we'll get to our minimal Haskell service. It doesn't look so minimal right now, but this is a great example of a joke I like to tell about how an idiomatic Haskell program is 6 language extensions, 20 imports, and then 1 line of Perl. And so this program is almost exactly like that. And I find that many applications, especially many servant programs tend to be like this because servant does a lot of type level programming. So it needs a lot of extensions. The servant package doesn't re-export a lot, so you need to import a lot of service dependencies explicitly to use some things. But let's focus on the 1 line of Perl. So first off, so what this service is going to do is we're just going to create a simple hello service. All it's going to do is read the database port to connect to from the command line. It's going to connect to the database, but do nothing with the database just yet. And anytime it gets an API request, it's going to just respond with hello world. And so the first part of this is just specifying how we parse the database port from the command line. So here I'm going to shamelessly plug one of my own packages called opparseGeneric, where if you give a Haskell type, like a Haskell record, it will auto-generate a command line parser for that type that will marshal the parsed command line into that record type. So for example, if this record has a connect port field, then it will generate a command line that expects a connect port option, and will make sure that option expects an integer for this word 16. And like, if, for example, if you were to wrap this connect port in a maybe, then it would make the corresponding command line option optional. So it derives a lot of that functionality for free. And it does so using the magic of GHC generics. So all you have to do is just say deriving generic and then deriving parse record, and then you automatically get a command line interface, including help output and completion for free. And it builds a lot on top of the wonderful opparse applicative library. It just enriches that with GHC support for data type generic programming. And so this is what allows us to just say get record options, and now we just bring everything that it parsed into scope without having to implement anything else for command line handling. This next part right here is what is the servant API type. And so if you're not familiar with how a servant works, the idea is that in servant you provide 2 things. One is a type representing the shape of your API, and the second thing is a set of handlers for each API endpoint. And servant will then make sure that the handlers match the declared type. And if you do that, servant will take care of all the marshaling in and out of your handlers for you. So for example, you don't need to take care of like explicitly decoding query parameters or form parameters or path components or JSON input or output payloads. Servant handles all of that for you. That's the main reason I picked it for this demo, because servant gets rid of all the marshaling and error handling boilerplate, leaving you with just very just almost pure code. I mean, you can have side effects too, but it's very simplified compared to most other web application frameworks. Here's the logic just for connecting to the database. So we take the connection port that we got from the command line, and then we connect to the database. We're just going to ignore, we're not going to use the database connection for right now. We'll do that in later slides. Here is the handler that matches our servant API type. So our API here says that there's going to be one API endpoint that expects the HTTP GET method, and it's going to return with a content type of JSON. And you can have more than one content type if you want, and servant will take care of that for you. And then it's going to return a value of type text. And so the matching handler just needs to be some action whose final return value is a text. And so in this case, we return hello world, so it matches the handler and servant accepts it. And then all we have to do is just serve our application on port 80, and we're good to go. So, but that alone is not enough to build and deploy our application to EC2. We're going to need to wrap it in some Nix code. And this is the part where Nix really shines because it makes this very easy to do. So first off, in Nix OS, systemd is first class. So Nix OS has taken a very opinionated stance that systemd is the init system that everybody's going to be using. And Nix OS provides a very easy to use way of authoring systemd services. So I can just say, I'm going to create a systemd service called simple Twitter. So I say systemd.services.simple-twitter. And then here are all the options that I'm going to set for my service. These first two options just ensure that my service will start whenever the machine starts. And it will also ensure that it won't start until after the database starts. So that because we depend on the database for our web service. But this next option is going to be the longest one, because what I'm going to do is because I'm trying to fit this all in one file, I'm going to be implementing a lot of logic in line along the way towards declaring what's the script that my service should be running. So the first step in order to actually create a runnable script is we need a working GHC installation. So in Nix, I can use a handy utility called GHC with packages. You give it the list of packages that you want, and it gives you on the fly an isolated GHC installation that has all those packages present in that GHC's package database, which is very handy. And so the next thing I need to do once I got the compiler with all the right packages is I need my Haskell source code. So I take that Haskell code that I showed you on the previous slide, and then I'm going to save that to a file called main.hs. That's going to be, and we use Nix's write text utility to save this file into the Nix store. And then we can refer to this file that we saved in the Nix store using this code identifier. And so now that I have a compiler with packages, and now I have my source file, I can build a simple Twitter executable. And so, one thing I forgot to mention really quickly is that so Nix has really nice support for multi-line strings. I wish Haskell had the same, because this is great. You use two single quotes, which you can think of as big double quotes, if that's easier for you to remember. And then here we can then just paste the Haskell script on the previous slide inline. I've truncated it a little bit, but just imagine it's all there. All right, so now we're going to build our executable that we want to run, and we'll call this executable simple Twitter. So and then here is basically a script telling Nix how to build the executable. This is not a really there's more professional ways of building Haskell projects using Nix, but this is fine for demo purposes. So we're going to use makedir to create an out/bin directory. Then we take the GHC that we just created, and we use that to compile the code that we created. And we tell it to write out the result to this /bin/simple Twitter output directory. And now we can use this executable to finally write the script to run our web service. And that's what this final part is here at the bottom. So we say, take our simple Twitter executable and run it. And as the connect port, make sure you use the same port that the database uses. And so this is another nice feature of Nix OS, is that it makes it really easy to make sure that various things stay in sync with one another. So for example, if I were to change the database port that my service uses, then the Haskell service will automatically be restarted to use so Nix will then change the value of this option to match the database, and then it will detect that it needs to restart the service to pick up the new command line as a result. So everything will always stay in sync, and you won't get broken links between services conceptually. And then there's other things at the bottom to deal with security groups. That's like some EC2 nonsense you got to deal with. I'm not going to go into detail about that. Okay, so if we take those changes and we apply them using Nix Ops deploy, it will download, not build, all of the services dependencies. So this is a nice benefit of Nix compared to like Cabal or Stack, which is that you don't need to rebuild all your dependencies from source. Very often the public Nix cache will have them already built and cached for you. But we'll need to build our service, since obviously that's not going to be in the public cache. And then once it builds a service, it will copy the built executable to the destination machine, and then it'll wrap that in a systemd service, and then we'll run it. And then if we were to deploy that and curl that IP address, it would then tell us hello world. And if you wanted to find out what IP address your service is using, you can say Nix Ops info deployment simple Twitter, and then one of the things it'll mention is for each resource for any machine that it manages, it'll tell you what IP address is there for that machine. We could provision a domain name and then use HTTPS. I don't do that in this talk, mainly to keep it short, and also because I didn't want to, buy a throwaway domain for this demo. But if you're interested in how to do that, it's actually not that hard, and I can talk to you about it after this talk. So now we need to take our HTTP service and create a real API that matches our Twitter endpoint. And this API is basically going to follow our, they're basically going to be one API endpoint per button in our simple Twitter website. So for example, here we have 1, 2, 3, 4, 5, 6, 7 buttons. And then so we're going to have 7 API endpoints, one per each possible button. And the mental model, if you're not familiar with how web applications works, is you think GET requests are like read-only requests, and POST requests are like requests that have some sort of a side effect. So it's like they set, well, I mean, really the correct HTTP method to use for setting something would be like put. But because we're using a multi-page web application style, we're limited to what the browser is capable of doing. And the browser, it only lets the user really just like click on links, or so the only things that are native to the browser without using JavaScript are clicking on links and submitting forms. When you click on a link, that's a GET request. And when you submit a form, that's a POST request. So we're restricting ourselves to those two HTTP methods. If we're using JavaScript, we'd have access to a much richer set of HTTP methods like put or patch or delete. And that would make this API a bit more idiomatic, or a more restful API. But for now, we'll restrict it in this way. So there'll be a GET request to get the global timeline, a POST request against the /user path component to create a user. And so just remember that every request has some HTTP method and some path component. And the reason we want to remember that is we're going to translate the two into our servant types. So here's what the corresponding servant type specification would look like. Before we get into the actual servant type, I just want to talk about these user-defined types that we're going to create. So there'll be 3 types that we use on the Haskell code: one for users, one for follows, and one for tweets. And we're going to use the same functionality of deriving a whole bunch of type classes using GHC generics. So for example, let's say I want to automatically decode a user from an HTTP request form parameters. All I need to do is just derive from form. What if I want to decode a user from database row? I can just say from row. And then similarly, if I want to encode a user into a database row, say for an insert statement, then I just use toRow. And then if I want to decode a user from query parameters instead of form parameters, then I just derive from HTTP API data. So, and this is where servant eliminates a lot of the boilerplate. So for here, for example, this is our, let's now go to our API type here. So there's going to be 1 line per API endpoint per button in our page conceptually. And the way you can read a servant API type is that it will first start with the path components that the API endpoint matches. So for example, if we have this /user/delete API endpoint, then the servant type will begin with user delete. And this is these are type level strings. And so servant actually does a lot of type level programming in order to create this nice little type DSL. And then the next part will be any inputs to the API endpoint. So for example, you can get inputs from the form parameters for a POST request. So for example, this says that if we create a user by making a POST request to /user, then we expect to get a user type from the request body, and we expect it to be form URL encoded. And then if we derive from form for our user type, then servant will take care of decoding it for us, and then just pass that strongly typed user record to our handler function. And then so after we've, one more example. This says that we expect the input to this particular API endpoint to be in query parameters, like in the actual URL after the question mark. And so servant will take care of decoding that into a strongly typed user for this particular API endpoint. And so after the input part of the type. Then comes the HTTP method that the API endpoint expects, so post or get. Then after that will be the content type that it will return. So it's far more common to use JSON, but since we're doing server-side rendered HTML, all these endpoints are going to return an HTML content type. One of the disadvantages of doing that is that the result that we return for every API endpoint is very weakly typed. It's just markup. That doesn't really tell us anything about what's in it conceptually. It's not a good API, but it is an okay multi-page web application. So for example, if we were using JSON, then we could return more strongly typed values like a list of ints or a string or a bool instead of just markup. But conceptually, this is how you read each of these types. And so the next question you might have is, how do I know what is the type of the corresponding handler for each of these API types? And Servant actually provides a useful utility that you can use to infer what that type should be. So there's a type level function called server that you can use within the REPL to ask Servant what the type of the handler should be. So GHCI has this useful : kind ! utility, which evaluates type level functions. And server is a type level function, which is exported by the Servant server package. And so you give it an API endpoint type, like this type for our global timeline API endpoint. And it says the corresponding handler will be something that runs in the handler monad and will return HTML markup. Or for example, let's see the handler for our /user for our API endpoint that creates a user. So it says, well, since this API endpoint will expect the user from the request body, then the corresponding handler will take a decoded user as its input. And since the handler returns markup, since the type says a markup return value, then the handler will return markup. So this is how you can know this is how you can detect and infer what handler type should be, which will make it much easier to author them. If you get it wrong, Servant will give you a very, very large type error. That may be a little bit difficult to interpret. So now let's actually write the handlers for each of our types. So this, for example, is going to be the handler for our global timeline button. I'm calling the handler index because it's the default entry point for the web page. And so what's another nice feature from the PostgreSQL simple package is that you can author inline SQL when talking to the database. And so here I'm actually writing some SQL which says, get me all the users and link them with their corresponding tweets, and then return the tweets in reverse chronological order. So this will be the global timeline. But what is unlike, say, a Java database framework, this is not going to return a weakly typed list of database rows. It will actually take care of automatically decoding a strongly typed list of user records. In fact, I don't even need to tell it what type of value to decode. It will use Haskell's type class system, which can piggyback on Haskell's type inference to figure out what type of value it needs to decode from those database rows. So I've actually elided the code for rendering the global timeline here in this ... But if we were to include that code, then the Haskell compiler would be able to work backwards from that code to infer that this tweets value should have type list of tweets. And then from that, it'll be able to infer that it needs to decode each database row as if it were a tweet record. And then you remember a few slides back, we derived a whole bunch of instances for our Haskell types. One of those instances we derived for tweet from row. And so this is how the PostgreSQL simple library knows how to decode a tweet from a database row. So we're going to skip over the rendering logic for now. We'll cover that in just a second. There's one, and so some database commands, this is an example of how to, instead of decoding a value from a database row, we can encode it. So if I want to insert a user into the database, I can pass a user and just put in these placeholders for where we want to insert values. And then it will take care of unpacking this record and putting it into these values. It's still not as strongly typed as it could be. There's still a lot of room for error here, but it's still a very nice and slick way of doing things. There's one last handler I'm going to go into. I won't go over all of them, but this will be the handler for a user's profile. So a user's profile can have up to 3 sections on it. One for the list of people that they follow, one for the history of tweets that they've authored, and then the last is the timeline of tweets from people that user follows. And so this right here is the algorithm that made Twitter a $1 billion company, which is like take some user, and then from that compute all the people that they follow, and from that compute all the tweets that those people have authored, and then sort them in reverse chronological order. And so this is the famous, timeline algorithm. It's actually not the case anymore these days. So by default, Twitter no longer sorts things in reverse chronological order. They now have a more algorithmic way of sorting things. But there still is the option to get the old reverse chronological timeline if you want. So that's what we're implementing here. Any questions about that before I go on to how to render the results using a combination of HTML and CSS? Okay, let me see. Oh, that's a lot of questions. Okay, 1 second. Oh boy, okay. So the first question is, okay, what does deriving stock generic mean? So first off, the stock part in deriving stock is not required. But so you could have just said deriving generic. So GHC has actually several ways of automatically deriving the implementation of a type class. So some type classes that you can derive are built into the language. So every time you run, say, like deriving eq, deriving show, deriving read, deriving ord, those are built into the Haskell's implementation or standard of how to derive those type classes. Another way you can derive things is you can just say, like, if you have a new type wrapper around a particular type, you can say derive this type class as if this type were the underlying wrapped type. Okay, so that's using what's Haskell's generalized new type deriving extension. You can also say, like, I want you to use GHC generics to derive the implementation of this. Well, sorry, not GHC generics, but I want you to derive this type class as if I left an empty implementation. And very often, an empty implementation of a type class will trigger the GHC generics implementation. So you can imagine that if there's multiple possible ways of doing things, then GHC might be confused. So if I say, like, deriving from user, which type of deriving am I using? Is it the stock method? Is it the new type method? Is it the what's called the any class method? And so having that explicit stock qualifier clarifies the GHC which mechanism that you want. So deriving stock generic says derive the generic type class and do so in such a way that you're using the fact that generics is a built-in to the language way of deriving things for that particular generic class. Okay, let's see, what's the next question? It says, did someone take the site down? Let me check. Yeah, it looks like somebody brought down the site. So I apologize, people. I guess it wasn't as robust as it could have been. I'll try to bring it back up at the end of this talk. But yeah, it looks like the site is currently down. Okay, so is packages overloaded here in the inner scope? I think that's probably difficult to answer verbally. So I will skip that question, but I'll answer it in discourse afterwards. Is there a good resource on compiling Haskell projects with Nix? I think there are two resources I would recommend. So one is the Nix packages manual, which has a section for every language that's supported by Nix packages. And so there's a Haskell section that contains a lot of useful advice for getting started with how to build Haskell packages using Nix. I also have a repository of my own, which called Haskell-Nix. So if you search GitHub for Haskell-Nix and my name, then you'll find it. And it contains like some long-form tutorial examples for setting up Haskell projects using Nix. Okay, let's see. What is the next question? What are the slides generated in? They're generated in Pandoc. So Pandoc, and specifically they're using Pandoc's Slidy, S-L-I-D-Y, output mode for slides. And I can later on I can link the exact command I used for generating them later on in discourse. Next question is, what do you think about using a record for the servant API type and deriving the servant instances with generic? I actually already created a package which tries to do that. So if you search Hackage for I think it's server generic. There's a package of mine where I play with this idea of just defining a website as a record and then deriving generic and then creating a type from that. There are some limitations of the API. I think it's not quite there. It may have been designed a little bit wrong, but try that out and see if that's similar to what you were thinking of. Okay. Now, the next question is that SQL DSL type safe? And the answer is absolutely not. So this is, I mean, it's nice for just like automatically packing or unpacking records in and out of queries or commands, but it's totally not type safe. Truthfully, I think the right way of doing type safe database queries is not is not writing Haskell code that generates SQL, but rather I think like the right way would be to use SQL as an interface definition language, meaning that like given database schema and some sample queries and insert commands, then you derive a typed binding to those commands in various languages like Haskell or Scala or whatever. That's what I think is the right way of doing things. But there's not a lot of tools out there for doing that, at least in the Haskell ecosystem. Okay, so let's see. Oh, somebody mentioned that there is a Postgres typed package that provides a more typed way of doing this. So I guess there is a better solution. And the next question is there any tool that automates the Haskell Nix workflow? Partially, there is a Nix tool, which if you give it a Haskell package, it will auto-generate a Nix derivation for that package, which still needs a little bit of a wrapper. But that Nix tool is part of the recommended way of using Haskell for Nix. And if you read the Nix packages manual, which contains the Haskell subsection, it will teach you how to use Nix in the course of creating a Nix wrapped Haskell project. Another thing is that Nix contains a really useful command, which is called Nix -- shell, which given any Haskell project, even including one that's not Nix enabled, it gives you some Nix code that will probably within reason get you a buildable Nix environment for that project. So I use this very often when just hacking on other people's projects and when I still want to use Nix, even though they may not have Nix enabled their projects. Okay, so I think that's the end of this batch of questions. So I'll go on to the last section, which is rendering HTML results. Okay, so there are multiple ways you can render HTML. For example, you could use a templating language. For this particular demo, I chose to use the Blaze markup package, meaning that I'm using a Haskell DSL to build up an HTML data structure. And then at the very end, I render that to text that I serve as HTML. Actually, sorry, Servant renders that as text. I don't actually explicitly do that final rendering step. One of the reasons I like doing this way is it guards against generating malformed HTML. And the second reason I like doing things this way is that I get the full power of Haskell, the programming language, when authoring my DSL. And I'll show some examples of doing that in this slide. So what I want to do is I want to create a high-level DSL for creating these forms that are submittable and translating those to HTTP API endpoints. So I'm going to create 3 intermediate utilities for generating those forms. The first one will be called submit. And then submit, when given a label, will basically create a button which has that label, essentially, a submit button. And then we have a field utility, which if you give it a hint for the field's name, sorry, if you give it the name of a field, which will be like the hint for the field, and also be like the parameter to send to the backend, it will wrap that into a form field. And then there will be a last utility called form, which will then wrap buttons and form fields into a submittable form. And then I won't go into the details of how those are implemented, but once we have those 3 utilities, then we can create this DSL for authoring forms. And so the DSL corresponds basically one-to-one with the UI, except that it has to be linearized since we don't have a 2-dimensional programming language. Well, kind of, but so here, this will be for the first row of buttons. So in other words, the site's not up, so I can't really show you, but this would be the first row of buttons, which contains the global timeline. This will be the second row of buttons, and then this would be the third row of buttons down here. And you can read this as saying the first button will have a button you can click. So it'll have a global timeline button. If you click that button, it'll make a GET request to the root API endpoint. And then this next form will contain a create user button and a name field. If you click that button, it'll submit the name field as a post request to the /user endpoint. Then same thing, if I want to delete a user, there's a name field. It's a post request to /user/delete. So this makes it very easy to stamp out buttons. And it's much easier for me to reason about this than say like, inline HTML that has been templated. But that's not enough, right? That only renders the left-hand side of the page. And so we also need to be able to render the right-hand side of the page, which contains, the results from any particular command. And then we also want to add some boilerplate that every page has, like, the CSS, the title of the page, and so on. So that's what these utilities are for right here. These are eliminating a little bit of that boilerplate. So we say we have a wrap function where if you give it some results to render in the form of a body, it will put those on the right-hand side of the page. It will take those forms we authored earlier and put them on the left-hand side of the page, wrap that all in a bunch of HTML, add some bootstrap CSS for some default styling, and then give the page a title of simple Twitter. And so we'll use this wrap utility for all of our handlers so we don't need to keep repeating ourselves with that common shared boilerplate. I'll skip over this error handler. Okay, so now here is the actual implementation of the logic for rendering the global timeline. So we say, okay, I want to, so here, sorry, the database logic is the same as before. We get a list of tweets. We define a way to render a tweet, in this case as a list item. And then we can use Haskell utilities like traverse. So I say traverse, render tweet, the list of tweets. And then I wrap that in an unordered list, and then wrap that in the boilerplate that every page has. And then that's the result of my handler. Similarly, get users, we get a list of users. We specify how to render each user, traverse. The answer to everything is always traverse in Haskell. Wrap that in an unordered list, and then we're done. So let's go to one more handler, which is the logic for getting a user's profile. So as before, we make 3 database queries to get the 3 different subsections of the profile. And we specify how to render each subsection of the profile. And here we can take advantage of utilities from control.monad, so like the when utility. So here I can say, when the history is not null, then render the history section. If the timeline is not null, then render the timeline section, and so forth for the followed. This is what prevents it from rendering an empty subsection if that person has not followed anybody yet, for example. And that's it. That's all you need to do to generate, to render HTML with. Because remember, that servant then takes care of all the conversion logic for you. So let me also do one last check for questions before I conclude the talk. Okay, so no additional questions. So I will try to get the simple Twitter site back up since it went down. I hope that you can find the complete code there. So this repository contains instructions on how to deploy it yourself if you want to build your own little fun app based off of the example code there. And this repository also contains links to these same slides that I used to present if you want to review the slides later. And so I hope this talk convinces you that a combination of Haskell, Nix, and Postgres can be used to build real web applications. I think the main thing that's missing here would be like some sort of authorization, account management, so people can log in, and then some sort of schema evolution, as opposed to just like having a single fixed static schema. But other than that, it's basically there if you want to like take it and build it into something real. So thanks everybody, and that concludes my talk.
Hi, Gabriel. Thank you so much for the talk and for answering all the questions as well. It was very nice to see this sort of like self-contained practical example. So I think it will be very useful to people. So thanks everyone for watching. We hope to see you at the hackathon for working on the projects. Later today, we have the continuation of the beginners track, and we have 2 talks from the GAC track as well. You can find all the information on our website and in our Discord. Thank you for watching.